Hello everybody and welcome to STL Partners webinar on 5G's impact on global carbon emissions, where we'll run through some of the work we've been doing in this area and hopefully have plenty of time for you to interact and ask questions. In terms of the agenda, I'll briefly run through introductions and how the platform works and a little bit of background on context for what we've been doing. I'll then turn over to my colleagues who'll talk specifically about the study we've done around the impact on carbon emissions from 5G and the different scenarios we've modeled. And then we'll look at the implications of that for the industry and other industries more broadly before turning over for the last 20 minutes or so to a Q&A session. A little bit about who we've got on the webinar today. My name's Chris Barraclough. I suppose I'm the master of ceremonies. I'll be managing the next hour or so. I'll then be turning over to my colleague Phil Laidler, who'll be talking about the work we've been doing and the modeling and some of the methodology and the results, before Miran Gilmore will be picking up, looking at the implications of that for the telecoms industry and more broadly other industries as well. And we also have on the line Ian Mash, Director from the Transformation Office in Huawei, who will be available to give a perspective from the industry, and he'll be on the panel that we'll be running sort of Q&A, so do put questions to him. I've certainly got a couple of it ready already. I hope most of you know STL Partners. I assume you do. There may be one or two who are new to this who have picked up the information about sort of carbon neutrality and our views on that. We've been around for about 10-15 years. We focus very much on top-line growth and looking at new business models and helping our clients and the telecoms industry more generally stay ahead in a shifting, developing world. We publish research subscriptions, which are read by 15 of the top 25 CSPs. We also undertake advisory work, consulting for telecoms operators and the broader technology community. And then we run events, both private events, physical events, and webinars such as this, where we bring together folks from across industries to discuss and debate key questions. This piece of work and this webinar draws on a fairly large research study we did around 5G. We looked at the impact 5G could have on industry with a deep dive on manufacturing and healthcare. And we have coming up an event in Mobile World Congress in Barcelona on the 25th of February, a breakfast. We'll be looking in more detail at the impact 5G can have on CO2 emissions and the impact too it could have on the manufacturing industry. If you're interested in that, please do get in touch with us directly, and we can arrange for you to attend that event. It'll be held in the Meridian in the center of Barcelona, and then we'll be running taxis to Mobile World Congress, so saves you getting on public transport as well. Let me give a little bit of context for the discussion today and the presentations you're going to hear. And this draws on a sort of central thesis of STL Partners in terms of the changing nature of society in which we're living in and the potential changing nature for telecoms and technology. Socially, humanity, I suppose, is wrestling with sort of social and economic challenges. These vary by country and region, but I think if you look both at the ability to make resources available, whether they be people, employment, or whether they be capital, or whether they be skills such as the ability to treat and manage chronic diseases in healthcare, there is a resource availability challenge. But it doesn't stop there. There is also a need for us to utilize and use resources efficiently, increasing productivity in a more competitive world, but also, and we'll touch on this obviously in this webinar, the efficient use of energy, as well as other resources such as land and water, distribution of food. And then The third category, resource conservation, making our world more sustainable, managing climate change, pollution, waste, and so on. These are non-exhaustive. There are plenty more demands and challenges with regard to sort of matching and managing resources and matching supply and demand. And I think importantly, this is not a question just for governments or for enterprises or consumers. It's a challenge for all of us, and solutions will have to come from all constituents across society. Our view is that technology has now got to a stage where it is potentially able to provide solutions that can address these core fundamental social challenges. And to do that requires solutions that can manage more effectively the demand for and the supply of resources real time. And there are really three components that make up solutions that can do this. The first is the need for connectivity and exchange of information. We're in a world now with fiber, increasingly fibered up and increasingly faster, more effective connectivity, mobile connectivity through 4G and more recently 5G. We have computers linked together through the internet for the last 20 or so years. And increasingly, we're now having sensors being put into machinery, consumer products, and so on, enabling information to be connected to things. That's interesting, but what we started seeing in the last 5 to 10 years is a huge growth in the ability to extract insights from that connectivity, from the connection of computers and people and latterly things, in growth of analytics and artificial intelligence. We've seen a huge rise recently. And I think the third element that is, again, is a relatively recent occurrence is the ability to automatically take action real time. And the digitization of organizations and processes and the rise of automation has meant that we're able to respond to the insights we can extract from sensors in a real-time fashion. So 5 years ago, and even 3 years ago, we didn't have all of these technologies available and processes available. They're not yet mature, all of them, but they are maturing. And so we're starting to see the opportunity to coordinate resources in a way that's not been possible. And it's this that we have termed a sort of new age for technology and for society. If we go back to 1850, where the problem I think that people faced was the expense and difficulty in communicating, when Alexander Graham Bell and others came up with the ability to link people together through telecoms networks, we launched the communications age. It was connecting people together through voice and text communications and overcame the constraints of distance and time. During the 90s, we saw the connection of not just people to each other, but people to computers. And this was really the rise of the information age associated with the internet. And that resulted in a huge growth in digital entertainment and digital information being exchanged, and the ability to transact using small pieces of data and platform business models typically associated with the internet players, freemium and B2B2C platforms. The impact was a dramatic lowering of transaction costs, such that, as a music lover, you no longer had to collect analog music and build up your collection. You can actually access through Spotify and other platforms every piece of music that had ever been written pretty much instantaneously. But I think where we stand now is on the edge of a new age. And we've termed this the coordination age. And what's different about this is we're linking together computers, people, and things, consumer things, industrial things, that enable us to extract information and insights and take automated action instantaneously. And we believe that we're going to see a rise of further B2B2C platforms, largely decentralized ones rather than centralized around a single player. And the result of this will be better resource outcomes. So the more efficient use of resources. And this is the context, this coordination age, where we believe telecoms operators have a core and central part to play in the collaboration that enables better resource outcomes. That is the context for the discussion today around energy usage and particularly the impact of 5G on telcos themselves and through them on the world more generally. So with that, I'm going to hand over to my colleague, Phil Laidler, and he's going to talk about STL's study on 5G and carbon emissions.
Hi, thank you very much, Chris. So this is Phil Laidler. Just a little bit more for those of you joining. If you've got questions, we're going to answer them at the end of the session. What I suggest is you enter them when, and as you come across them, there should be on the right-hand panel, you should be able to enter any questions you've got. We'll try and address those at the end. Those that we don't address at the end, we'll address offline, and we'll be sharing with you, as well as sharing the entire deck with all participants. We'll also be sharing those Q&As. I should mention also, this is recorded, so if some of your colleagues are unable to join, you can get them to listen to it as a recording. Great. So before I just kick off, a little bit about myself. I head up the consulting practice at STL Partners, and I led the work that I'm about to share with you on carbon emissions from global mobile networks. My own background, prior to joining STL about 11 years ago, I was at Verizon, and between my 7-8 years at Verizon and joining STL Partners, I actually set up a home energy efficiency business in the UK, and then I worked for about a year for the Carbon Trust, launching a new venture. So I have a particular interest and background that straddles both telecoms and clean tech, and that's possibly why I've got some interest in this. That's a bit of context for myself. Anyway, about this research project that we're going to share some details on, we were given a task. This research was funded by Huawei, and they asked a question: what is the impact potentially of 5G and the speed at which 5G is deployed on global carbon emissions from mobile networks? And that was the task we were set. That was the question they posed to us. And essentially, they asked us, well, what we chose to do was to model carbon emissions from mobile networks for 220 countries, each country, obviously, in a big spreadsheet, and come up with some scenarios about what might it look like in terms of carbon emissions under these different scenarios. What I want to run through today is high-level findings, and more importantly, I'm going to invite Miran, my colleague, to try and share some of the implications, the so what of this study. A little bit of background. When we think of the impacts of 5G, and I'd like to highlight this isn't just mobile networks or networking in general, it's specifically 5G. So where does 5G make a difference on 4G? When we think about the impact of 5G on carbon emissions, we think there are 6 broad categories where there are impacts. And they're the ones set out here. I don't need to read them to you. But needless to say, today, we are going to focus on these 2. So we're going to focus on carbon emissions resulting from core mobile networks and the access networks of mobile networks. So that's really where we're focusing today. I think it's worth stressing that 5G is going to also impact carbon emissions in a whole host of other areas. It's going to have an impact on device and emissions associated with devices. It's actually going to have an impact more specifically on helping to decarbonize the grid. And last week I was at a conference where the renewables industry was brought together, for one of the first times, in fact, by the GSMA and the European Union, where we're brought together by the European Commission to talk about how the 2 industries could better work together to help with the mission of making the grids more low carbon or no carbon or carbon neutral grids with new renewables. And there's a big role for that, which we will touch on later. The third area is just generally improving efficiency, reducing waste, helping performance across all of the sectors. And then I think there's a specific one more related to reducing travel and reducing transport costs. And I would argue that the impact that 5G can have on these four is way in excess of its impact within our own. Having said that, we have to get our own house in order, and this study focused on the third. During the course of this year, we as STL Partners will be looking at these others too, and we'll be working with the GSMA and with the renewables energy industry to understand what these other impacts could be and help quantify what is this defined often as the enabling capabilities of 5G. How can 5G enable benefits beyond our core networks? But for today, we're focusing on the first one. We will mention the others later on, and this is the context of today. A little bit of a high-level summary of how we proceeded to do this modeling. What we did, and this is perhaps the biggest assumption in the model, and I know we're going to have a discussion on this because it's the big one, is we projected current mobile volumes in terms of the terabits of data being, or terabytes of data being transmitted every day. And we projected that as an ongoing growth. And that was a static assumption. So that applied throughout all of the different scenarios. We then split some of that data onto 5G networks, some onto LTE networks, and then for each of those two, we did this for every single country. For each of those two, we then had a set of assumptions regarding the access and the core energy performance. In other words, how many gigawatts or how much energy in electrical energy is required for delivering each of those bytes or bits of data. And then we took the result of that and multiplied it by what we're calling the carbon grid intensity. In other words, how much CO2 is emitted for every unit of electricity that's consumed by the network. And then that gives you your carbon emissions. And you run that over the different scenarios, and the difference between the scenarios corresponds to that impact. I mean, this is the fundamental sort of formula and the assumptions that went into the modeling. And it's important for two reasons, partly because it's how we modeled it, and therefore to understand the outcomes, you need to understand the modeling, but also because it shows you where the levers are for operators in the industry. If they want to take an approach to reducing their own carbon emissions, they have a number of points they can do that. And one way they can do that is obviously to reduce their traffic volumes or reduce the growth in traffic volumes. Not terribly desirable, but that's one way. The other way is to improve their carbon or reduce the carbon intensity. In other words, to have more renewables that are going into their energy supply, either for their off-grid, in other words, renewables provided themselves, or on-grid by mechanisms such as purchasing power agreements with renewables firms, where they are creating additive renewable supply just for themselves. So those are the two ways, but also they can improve the speed at which the 5G and the 4G networks energy performance, and both of these will show performance over time, and that's an important thing to understand. It's not static. 5G networks over time will get more and more efficient. So will the 4G networks get more and more efficient. And what we need to model is how much better will the 5G get over and beyond the improvement that will be achieved through 4G. And then finally, the other lever that they've got is how much of the data will go over 5G versus 4G. And the biggest way that they can accelerate the amount of data on the 5G is to accelerate the 5G rollout, because then the 5G networks will end up carrying more of the traffic, and that will overall deliver a lower energy use and hence lower carbon emissions. So that's the fundamental equation that we ran through the model. And I think we're going to get some questions and some debate about this, but it's important to understand that that's how we've approached it. It's also important to reflect where and what you can do as an operator to tackle your carbon emissions. In summary, this is after we've crunched the model, 220 countries over 10 years and 15 parameters, et cetera, et cetera. It isn't a massive surprise. What you get is this: if there is no 5G, you get this top line growth. This is actually well below, by the way, the growth in data. In other words, the no 5G still assumes lots of savings are being made. Lots of savings are being made and lots of improvements in energy performance on 4G and lots of improvements in carbon intensity of the electricity network. So even that curve assumes a lot of improvements, because the actual curve for data growth is way beyond this. It's way above that. It's almost double that. So this already captures a big saving and improvements. And then the other three are pretty self-explanatory, and there's no real surprises. They do converge over time, but over that middle period, clearly a fast G rollout sees a lot more benefits and a lot bigger reduction being achieved versus the others. I mean, we don't get to zero. There's still plenty of work to do, and it would be nicer for us to get to. The only way we're going to get to zero is by being able to adopt more renewables sooner than we've modeled here. We've been relatively conservative with our assumption set regarding renewables. And I think as an industry, we can move faster than this, but we've taken that assumptions for the purpose of this modeling. And that adoption of renewables would impact these four curves in the same amount. So it wouldn't actually affect the outcome of this. It would just have all of these lines coming down a bit faster. If we want to try and break down, where is that improvement in performance being achieved? Where are we outperforming the growth in data? So again, imagine there's a line just for data growth. How are we outperforming this very steep 20 to 30% per annum data growth? Cumulatively over the 10-year period, we've added up here the key contributing factors, the key technologies. The first one is grid decarbonisation. Here, I think we've got relatively modest assumptions. I think we could hope that the industry could adopt more renewables faster than the national grids. What we've assumed is actually something more along the lines of national grid. I think the industry can outperform that. So this could be better, but it won't actually affect our overall findings. The next one is the 4G core improvements. We expect and anticipate that improvements in performance on the core and on the 4G core will yield significant reduction, improvement in efficiency, and therefore reduction in carbon emissions than if there were zero improvements in the core network. And we also expect some significant improvements in 4G radio. This is to do with being able to put some cells or some sectors or some carriers to sleep within the 4G network, so you can introduce energy saving measures within 4G. You don't have to wait for 5G. And then we see a relatively modest improvement from 5G core rollout, but a big improvement from what we've called broadly new radio. It's a bit more than just new radio because it includes MIMO and includes a bunch of other technologies, but essentially from the access part, we expect a significant saving that 5G can bring. Finally, mmWave does help, but it comes a bit late. So the reason this looks low is because we're looking over the whole 10 years, and most of the impact of mmWave comes in a bit later. So if you just did this for the last year, this last block here would be a lot bigger, but it's coming a bit later, therefore the savings are not seen until later on in the cycle. So that's the overall saving. And behind this, there's a fundamental assumption. I guess this is at the heart of the modeling exercise. This is at the heart of the assumptions that we made. And that's the observation that today, as an industry, we have a certain average access network load or performance. In other words, how much energy is required for delivering each big gigabyte or exabyte of data. And that takes in all the averages across all of the networking, the rural as well as the contract sites. But to say as an industry, we tend to leave the lights on, right? So we have our network on pretty much the whole time, pretty much on full. There's no attempt to try and manage any of that, and a lot of the time, some very empty elements of the network are running with the lights full on, if you like. So it's not great, the performance. And we would project by 2030, even that 3G and those 4G networks could see a significant improvement in performance. Could be more than this, but this is what we project. So, and actually, that paradoxically, the more 5G you have, the better 4G performance you can get because of the way that the two interact and the way that the 5G network allows you to essentially manage peaks and troughs, and therefore run your 4G or your 3G networks much more efficiently. So that has an impact as well. We've then looked at what we think are realistic initial 5G performance figures, and we also believe they can improve, and we then overlaid on those the mmWave improvements and that over time. So these are the key thing to notice here is that we are assuming an improvement in performance over time. What I'm showing you is the average, because every country or every groups of countries have different performance, but this shows you the heart of where is that saving coming from? How are we achieving the benefits? Essentially, this chart captures and reflects that. A quick word, because we've talked primarily about performance of network. What we haven't talked about is the grid intensity. In other words, how dirty is the electricity? How much carbon is required to generate the electricity? And that varies dramatically across the globe. So of course, the model has to capture not just the as is, but the model has to project that over the next decade. And so lots of different assumptions have to go in there. And what we've used is the overall grid, which is perhaps slightly generous for some operators and slightly unfair for others. And we do think that operators can outperform the carbon grid intensity by adopting more renewables themselves, either directly onto the network or through vehicles such as PPAs. So I don't want to spend ages on this chart, but just let me explain it first. This was modeled for each individual country, and you can see on this chart on the lower axis the relative carbon intensity of the electricity grid in 2020. So that's a sort of key assumption. And countries to the further right have a relatively high carbon content of the grid. In other words, their electricity generation is primarily through fossil fuels. And then the ones on the left have a very low carbon grid intensity. In other words, their electricity generation is primarily through renewable sources. And then on the other scale, which actually is a logarithmic scale, we're seeing what is the cumulative carbon emissions that can be reduced. In other words, what we think a fast G rollout can help reduce for all these different countries. So it's the size of the prize, of the potential prize on the other axis. It's also a reflection of the relative carbon intensity of those countries. So you can spot your own country here, and I don't want to draw out too many conclusions. There aren't that many surprises. It's just that some of the countries that are in the top right-hand side, clearly there's a big opportunity here, and it should be a big focus. The ones on the bottom 11, I don't think they should sort of say nothing to do, because there's always something you can do. But clearly, you know, the opportunities are up on the further right-hand side of the chart. And if you want to know more about the specific numbers for your country, do contact us. We have a big table with all the numbers in there. We're happy to take you through the assumptions. So what were those assumptions? As I said before, the biggest single assumption is that data volume growth is the same under all scenarios. You know, I think some of you will already have spotted this, and you will say, but surely 5G will generate more demand. And I think, you know, that's a fair comment. It's a fair criticism of this approach. But we had to do a like-for-like study. So anything else would have involved making more assumptions, very difficult to justify. So I think we want to be open about this. We want to share with you this is the assumption, and acknowledge that, you know, realistically, if we didn't introduce 5G, we probably would see a curtailment of growth in traffic, and that therefore the associated emissions would be lower. But we had to come up with a modeling scenario that let us compare things like for like, which is why we stuck to that assumption. There are some other assumptions relating to the embedded carbon emissions and what we call scope 2, scope 3 and scope 1 emissions. This study has focused on scope 2. For those of you who are familiar with the terminology in carbon disclosure, scope 1 is to do with your actual activities, such as your truck rolls, your vehicles, your direct generation of carbon emissions. Scope 2 is more specifically your electrical power, and that's what this study has focused on. And scope 3 is more to do with your supply chain and the embedded carbon within your equipment and within your capital investment and activities associated with those. What we've assumed essentially in the study is that across the scenarios, scope 1 and scope 3 are both relatively small and fairly comparable. I guess a refinement could be to look at those again and see, you know, how would they impact it. I'd say that for telecoms today, 85% of our carbon emissions are from scope 2, and therefore that's what this is focused on. Right, so that's in a nutshell where we've got to. Now, before we hand over and talk a little bit about the implications, we just want to get your feedback on what you've seen in the last 15 odd minutes. So we'll just put up these polls. Our first question to you, just bear with us a sec, is what do you think? Well, actually, our first is about you and your company. So just like to understand from your perspective, you know, how would you summarize, and this is anonymous, so we don't know who's saying what, how would you summarize your company's attitude or approach to carbon emissions? Would you say, look, it's fairly nominal, we have the solar panels in our annual report and the pictures, but it's pretty much, you know, lip service. You say, look, we're trying, but it's a bit haphazard, it's not that well organized? Or do you think, no, we've got goals, we've been very public on what we want to achieve, and we do have a plan of sorts to get there? Or you think, actually, we're pretty seriously committed, and our senior execs have even got their bonuses, and we're all very aware, and it's something we're continuously updated on and made aware of in everything we do? Or would you say, look, this is fundamentally part of our DNA, and we would consider ourselves, you know, global leaders? So I just want to give you not too much more time to vote. I'm just having a quick look at Jonathan. Are we getting any results? What's our number? Yeah, okay, I think we're good. We're good to close off on that. So let's see what you think of your own companies in terms of commitment to carbon emissions. Okay, that's interesting. So overall, there's recognition that you're in the middle ground, so clear goals and a plan to meet them. About an eighth of you see it as deeply part of your DNA. I suspect they're Scandinavians, but there are non-Scandinavian companies who I think could make that claim too. So it's not just down to them. And then there's a few here who clearly are a little disappointed by their company's lack of commitment. But I think that's probably fairly good summary of the industry from what I've seen. So I think that's very good. A good spread, and some of you may be a bit harder on your companies than others, but thank you for that. The next question has more to do with what we've just presented. And the question there is, well, what do you think? You know, we set out some analysis, some thinking, and I'd just like to get honest feedback on how you see that. So if we could just see the next poll, Jonathan. This should come up in a sec. How useful was this view? So if you think, well, this is pretty disappointing, it's pretty undermined, you've oversimplified things, not really, let's put that one in. If you think it makes sense, but there's nothing really that unexpected or new, vote that one. If you think, look, this is helpful, but I still don't understand, you know, what we should do as an industry. It doesn't really tell me the so what. And that one, if you think, well, actually, there's some pretty valuable insight here, we can use this, I'd like to, you know, put it to good use. Or if you want to see more detail, click there. So it's pretty obvious what the score is. Just want to get your feedback, your initial thoughts on what you've seen, where we've presented here today. So look, if we get a few more of you, don't be shy. I can take the criticism. Well, not too much, just a bit. Okay, let's have a little look at what we've got here. All right, there again, pretty mixed. So some of you do feel that it's pretty oversimplified. That's fine. I think that's fair. That's why we've got this question out there. And a mix of things across. Okay, good. So we've got to range the audience. It may be because you're coming from different positions, different situations, backgrounds, but we've got a response. So look, feel free to put more of those into the questions. We'll do our best to address them on the call, and we will then follow up offline with the questions. Yeah. So what I'd like to now do is hand over to Miran, who's going to take us through a little bit more of that so what.
Yeah, so as Phil said, I'm going to be talking about what the implications are for you and go through a few recommendations that we have for different players throughout the industry. So I'll start by talking about what operators could be doing. This first one, not particularly revolutionary to those of you who have been paying attention, but it is simply just to accelerate your rollout of 5G networks. Should seem obvious based off of what Phil's explained, but it really is important to note because this is going to be a really key step for operators in reducing their carbon emissions. We also think there's a role for operators to play in providing better support for their customers in meeting their sustainability objectives. So there's various things that you can be doing to help your customers reduce their carbon footprints. And as part of this, reducing your own footprint will be a key step, but also you could be playing a role in enabling insights into the business and supply chain. You could be doing more to enable automation. So for example, virtual meetings. Obviously, if you're able to meet virtually, it cuts out on the need for travel and the time and energy associated with traveling. Or if you implement smart meters, then you won't need to send as many employees out to measure the meters. So it's really about supporting customers to optimize their processes and cut down on their waste. And we also think you could be helping customers to use cleaner energy. So traditionally with fossil fuels and non-renewable energy sources, the supply always meets the demand. So if there's a peak in demand, you just burn more fuel to meet that. But as our use of renewable energy sources increases, we're going to end up moving towards a world where supply of energy is variable. Obviously, the sun, the wind, it doesn't produce a constant supply. And so demand is going to have to meet this. And this is going to require us to alter the way in which we consume energy. So, for example, with charging an electric car, instead of plugging your car in at the end of the day and expecting it to immediately start charging, you could have a delay and the car might not actually start to charge until the middle of the night when overall demand for energy is lower. Or you could have the same thing with a water heater where it's heating the water at times when there's less demand for energy. And so this new approach to energy consumption and energy use is going to need a whole new ecosystem and a lot more coordination and capabilities. And within this, operators are going to need to take on new roles and new business models to be able to support their customers with this. And we also think there's scope for operators to help customers more generally with their emissions reporting and their disclosure. I think it's also important that operators are able to better quantify the full benefits of CO2 reduction. So at the moment, you're not really quantifying systematically the full end-to-end business impact of reducing emissions. And it's really important to be able to find a way to capture the value and calculate what the NPV is of making these changes to reduce your emissions, because the benefits go so much more beyond just the reduced energy costs. So for example, you also get lower cost of capital because investors are increasingly marking down companies that don't show any evidence of taking actions to reduce their carbon footprints and follow sustainable practices, because they see them as potential liabilities and they could potentially become stranded assets in the future. You also have a lower exposure to regulatory action. As governments are coming under more and more pressure to meet sustainability targets, they're going to start becoming more interventionalist in their actions. And so companies that act now and start taking measures now to make these changes and reduce their emissions are going to benefit in the future from having lower exposure to government's regulatory action. It's also something that really matters to employees. It's an issue that a lot of people feel extremely passionate about, and in particular, younger employees who have the digital skill sets that operators are looking to attract really want to work for companies that are clearly making an effort to be more sustainable. And finally, it matters to customers. They want to work, again, they want to work with companies who act sustainably. It's something that they expect. They're increasingly coming to demand this. And so there's a lot more in terms of what the benefits will be for your business beyond just, oh, it'll save me money on energy. And it's really important to be able to fully capture and calculate that. Now, we've also got some thoughts on what vendors and technology providers could be doing. So the first one is the setting of industry design standards. So we think it's important that we set out some clear, sustainable design standards for telecoms networks. So standards and benchmarks, ideally at the global industry level. And these could either be standards on the product level, similar to the energy ratings on white goods, like the ratings on fridges, that would indicate how efficient all of the individual components of networks are. You could also have standards on the network level. So that could take a similar model to the BREEAM scheme, which is an international scheme that provides a third-party assessment of the sustainability performance of a building. So that considers both how sustainable the actual building is and how well it was built, what materials were used, how efficient its components are, but it also considers how efficiently the building is used. Because obviously you could have the most sustainable building in the world, but if you're always leaving the lights on, you can't really claim that it's a efficient building. And what's really interesting about the BREEAM scheme is that it's not regulated, it's not set and driven by governments, it's actually a fully industry-led initiative. So you could have the equivalent scheme for networks that assesses how efficient networks are, and it would be possible for that to be fully driven by the telecoms industry. We also think that there's potential for vendors to extend their business models that they have with operators. So this would be developing a model similar to what the energy saving companies is. And these guys work with buildings, and what they'll do is they'll go into a building and they'll do it up and do it over, for example, changing the light bulbs and making its components more efficient. And they do this all for free. And then the customer will ultimately be saving money from these changes, and the money savings will be split with the energy saving companies. So everyone's happy, you know, the customers got their building made more efficient for free and they're saving money, and now the energy saving company has also saved money. And we think there's scope for vendors to be able to develop new business models and extend their existing business models to be able to offer a similar service, but for networks rather than buildings. Now, regulators and other authorities also play a part in this. The first one that we think is really important is to be setting more low carbon targets. So we don't see why there aren't, well, we don't think there are currently enough targets for people to work towards, and regulators should be setting these targets within their license terms. We also think it's important to incentivize rollout of 5G, to try and accelerate that using policy and licensing to really drive people to want to do it faster. Encouraging efficient practices is also important, whether this be by network sharing or by encouraging use of lower carbon energy sources. They could do this potentially, for example, through lower energy taxation. And finally, incentivizing that move away from 2 and 3G networks and incentivizing people to decommission these early as possible. I know we've sort of been through it a lot in this webinar, but it really is important to move towards the more efficient networks as quickly as possible, and that's going to have a huge impact on cutting our emissions. Now, finally, we also have some industry-wide initiatives. So these are some points that we think will help focus the industry and really drive it towards this common goal of becoming more sustainable. The GSMA currently has some good initiatives, and some telcos have set themselves carbon neutral target dates, and this is all great, but there's clearly still a lot more that could be done. So one thing that we've proposed is this 1 watt challenge. So the idea is that we'll focus down on a single metric, in this case 1 watt per megabit per second average performance, and this is really going to focus the industry to converge on something that's simple and intuitive, and it's a quick snappy target figure. Doesn't necessarily have to be about watts. It could be 1 joule per megabit or 1 gram of CO2 per gigabyte, but we've chosen 1 watt because we think it's quite clear and snappy. And it's kind of similar to what the airline industry have done in converging on the measure of grams of CO2 per passenger kilometer. Except obviously it would be for networks, and in the same way you could use it for just measuring having a goal to work towards. And this is really great because it doesn't take into account the source of the energy. So it's not going to penalize operators who are in countries where all of their energy is fossil fuels and they're limited to using that, because obviously on the whole, they're not going to appear very efficient, but it's still great for them to have something to work towards and show that they are making cuts. And this will be complementary to the wider carbon neutral targets that a lot of operators have implemented. And we also think it's important that we become more open in our reporting of how telcos are performing. So we're suggesting creating and maintaining a scoring and a ranking of telcos, similar to what they have in the airline industries, except in the airline industry, the scoring is largely driven by kilograms of CO2 per kilometer, and in telecoms, it could tie back to that key metric of 1 watt per megabit per second. And this is really important because it would be great to really highlight the efforts of people who are making good changes and acting really well and sustainably, and really recognize and applaud their achievements. And it would also increase visibility within the industry and really push people to strive to be better and just bring together the industry as a whole to want to refine their practices and maximize their performance. So I'll now pass over to Chris, who has another poll for us.
Thanks, Miran. We'll just pull that up. I appreciate this was a whistle-stop tour through both the research and the implications of that research, but we've hopefully given you a selection of recommendations for both the industry level and individual players within it. And we'd really like your feedback on that. It'd be very useful for us in terms of prioritizing our efforts. And I guess we've got 4 responses here. One, which is ranging, I suppose, from hoping, great, but hoping you were going to do a little bit more ambitious, more ideas. Some food for thought here, useful input. We'll see what we can do. This is good stuff, and I think we'd like to see some of these taken forward. So, perhaps somebody else can do it or somebody else in the organization, through to there are solid ideas and we'd like to pursue these further and so more concrete. It'd be great if we can get your thoughts on overall how valuable you think what we set out. Appreciate we've not spent long on them and it's been a fairly rushed, but hopefully you've got some thoughts. If we can see the results of that. Okay, so a range of views here, and I think fair comment for those who are looking for more ambition. I guess we'd love to have a discussion with you about the kind of things you are thinking about, because we are, we're focusing on this. We think it's important ambition. And others, there's a range of views. It looks as though we're kind of thinking, yeah, it's a good solid start. There's a lot more to be done. And I guess that's where we are. We believe there's a lot more to be done here. But that's useful input. Please do reach out to us. As I say, we've got the event at Mobile World Congress. So that's one place you can do it. Otherwise, you can contact us at any stage and we'll be certainly sending out this webinar recording as well and the slides and so on. So we'd love to have a dialogue with you. If we can just go back to the presentation, that's great, thank you. So I guess before we turn over to a Q&A, I just want to sort of summarize our sort of overall thesis here. And I guess, at the start, I set out by saying that I think we're on the cusp, and STL Partners believes we're on the cusp of a new age, one where the efficient use of resources is critical for the society in which we live, critical for governments, enterprises, and consumers. The ability to help corporations and governments interact more effectively with each other and with their customers is important. And our belief is that in some ways during the information age, with the rise of the internet players, telecoms felt disintermediated. There is an opportunity here to re-intermediate themselves by playing a bigger role in the collaboration of different players within ecosystems, and having 5G networks that are both able to help people interact and companies interact faster through low latency, through edge compute and so on, but also having efficient 5G networks will support that efficient use of resources more generally. And our belief is then that a drive towards carbon neutrality is potentially a central plank to telecoms and their growth strategy. This is not about CSR. This is really potentially a core part of a sort of collaboration age growth strategy. And therefore we at STL Partners, we're focused very much on growth, on top line growth for our clients. We believe that this could be an important part of that. And we'd love to get your thoughts and responses to that. So we're going to turn over to Q&A for the last 10 minutes or so. Sorry, we slightly overran in terms of the presentations and polls. But I want to introduce to you and kick off Ian Mash from Huawei, and I think Ian is now unmuted. So Ian obviously works for a global supplier and partner of telcos. And Ian, the question I've got for you is, have you got any specific examples of best practice from operators in terms of reducing carbon emissions? Any examples from specific operators or regions?
Well, yes. I mean, I think, this has been a great presentation, and I think you've covered a lot of the stuff that I could have talked about here. So thanks for that. But basically, I mean, I think there are some examples of people and countries that are taking the bull by the horns and rolling out quickly. I mean, UK is one of those. EE is going for a very fast rollout, and they're being matched by Vodafone and O2 and 3 running close behind them. China Mobile is going for a massively fast rollout of 5G, and the feedback is that that's because not only do they see 5G as economically viable and will lever their business corporately, but the efficiency of the network is something that they want to get involved in. And I also do a lot of work with some of the tower companies and the people who actually own the towers that the mobile vendors put their, the mobile operators put their equipment on. And these guys are very interested in the 5G environment. I mean, clearly, what we're not saying is that 5G is going to be cheaper to roll out, because the growth of data is continues at a very high pace, and we see no end to that at the moment. And the innovation of the ecosystem around 5G, I think, will keep that rolling upwards for a number of years. But what we're saying is that on a per bit basis, as you said, 5G is more economical. So you could try and run these networks with a less efficient service like 4G, but 5G is the way forward. So I think, you know, the concrete examples of those sort of companies, we have 60 commercial trials or 60 plus commercial trials in Huawei at the moment on 5G. And so we've gone from a couple of years ago where people were saying we don't see the need for it to 60 commercial trials. And those are people starting to see that, you know, there are benefits not only in speed, but in terms of efficiency and carbon neutrality going forward. And obviously I don't want to say who those are specifically. But certainly, as we all know, the ones in the UK, China, Korea are forging ahead very quickly.
The technology is one part of it. This is, you know, a question for Phil, Miran, and yourself as well, Ian. Technology is part of it, but is there anything that can be done in terms of the business model as well, the commercial side, that will drive faster adoption? Or are we seeing innovation from, you know, in terms of business models that will, you know, potentially reduce carbon emissions from operators or others within the technology sector?
Well, actually, I thought there were some good examples that Miriam was picking up on earlier. And I think one of the things that I don't see much in operators, and it may well be that, you know, I'm not shown it and they are doing it, but I think one of the things that it would be useful is to have a wider discussion across their business about what the needs are for the company. So technically, the technical guys get very excited about the speeds and the capabilities of the network. But I also think, you know, the commercial guys should be thinking about the other side of things, like, you know, the actual cost of the electricity to run the business. And I know a lot of finance directors that I've met are quite keen to understand the things that we can do as a company that will help them in those areas. And it's not just about the specific technology efficiency, but it's other things that we'll do. I mean, last year, for example, at NWC, we had sort of echoing your 1 watt challenge, we had the 0 watt, 0 bit view, where basically, if the network's not being used, it turns itself off, and the AI system works out, you know, what's a good time to do that. And it's only if someone needs to make a call in at that area that the network then comes out from its hibernation and powers up again. Mm-hmm. And so that, you know, reduces a lot of power usage. Other things that we've seen in that we've got in and have provided interest in places like Africa, where they've got a lot of potential for solar power, is that you know, a lot of the network is set up at the moment so that when the battery power dies down, a diesel generator kicks in and powers the battery right up. And we've got software and as part of our AI suite that will say it's very clever. It knows that the sun's coming up in the following morning, and so it doesn't power the battery right up. It only powers the battery up to a certain point, which it thinks can cope with the traffic volume that it's going to get in that period of time, and then lets the sun do the rest the following day. So there are things that, you know, we're doing and we're looking at. But I also like some of the innovative models that Miriam was talking about as well.
Phil, any thoughts?
Yeah, and I think, there's actually been a couple of other questions from the audience relating to this metric. I think there's a question from Ulrich regarding whether we shouldn't be doing this on a per volume rather than megabits per second. Yeah, we kind of went for the 1 watt, which is the same as 1 joule per second. To go with 1 megabits per second, we could have gone for 1 joule per megabit, or we could have gone for other. And it doesn't really matter. It's whatever people can hang on to and see. The benefit going for 1 watt per megabit per second is you can, and we're currently quite a lot higher than that. I think we're almost an order and a half magnitude above that. So it's a long way to go. But the benefit going for that is that you can reach that at certain points in the day. So you can say we achieve the target for 10% of the day or for 20% of the day. So you can kind of show how well are we doing towards achieving that as an average. So it's something that you should be able to report on. It's kind of like an optimization performance. But I don't think we want to get too bothered about it. We just want to try and find one that captures the imagination and people can focus on. I think there are a couple of other questions. Not sure how much time we've got to answer them, but
well, I think one question is, we've set this 1 watt per megabit per second. Where roughly is the industry now? Is a question we've had, and I think it's a reasonable question to ask.
Yeah, and I think we need to double check on that. I can check what we've got on the assumption set and share that with the audience. I don't want to do it off the cuff, so we want to go back to the spreadsheet and double check. I think it's something like 20 times that. So we'll double check and
that, as an order of magnitude, that's the kind of reduction we're talking about. Okay, that's interesting.
So it's a significant improvement. I think there's some questions here that question whether it's possible. The laws of physics say, well, they do. The joules per bit.
You should explain the question.
The question that's been asked by Peter is, the laws of physics say bandwidth is determined by joules per bit per kilometer squared. So I think the question is, to deliver more bandwidth will always mean more energy and less or less kilometers squared. And I think that's the point of bringing on mmWave, is that you're obviously reducing your footprint and therefore your power required. It's true, but what we're able to achieve with MIMO and efficiency and extract more efficiency out of the network is an ongoing thing. And what we have seen is what's experienced in the network today is, orders of magnitude above in terms of the consumption of energy per data load transmitted, order of magnitude above what we're reporting in the lab. So simply by getting closer to what's in the lab, that in itself will get us a long way. In other words, more optimization and more improvement. And it is true, we end up with smaller and smaller cells as we go up the frequency stack. And by smaller and smaller cells, we're able to deliver more bits of data for the same unit of energy. Just like Wi-Fi is incredibly efficient, but a very small footprint. As we move up the spectrum, we should be able to get better performance. Of course, as a denser build out, but in terms of energy performance, we extract that. So that's what I would respond to that question. I think there's one more question I want to just pick up on. The question says, in this analysis, have we included the backhaul networks? And we have. We've included that. It's not just access, but today access accounts for mobile networks, account about 70% of the energy load and therefore carbon emissions. That's going to change. And in the model, it actually shows that we're expecting or anticipating bigger improvements in access than we are in the backhaul. So the backhaul becomes more significant because the savings being made in backhaul are not as significant as those in access. So that there's a slight shift in that, and the model shows that it becomes more parity over the course of time. Things like edge compute will change that, because in fact, what we'll see is more network loads in the access network not going into the backbone, into backhaul, but being managed, treated, and delivered and responded within the access network. So it's complicated. And in fact, the whole exercise is incredibly complicated. What we've got is some fairly general summaries that we're using for the modeling. For sure, more work can be done, but what we wanted to capture the broad shape of it and understand the key drivers. So I think we're kind of running out of time.
Yeah, we're running out of time. You also, the more alert of you would have noticed we're running out of power because we had a screen pop showing that our batteries were low. Just to wrap up, and thank you for the detailed question. The devil is in the detail here, and please do reach out to us to find out more about the model. You are clearly an interested audience in this. We'd like to have your input on that because we believe there is scope to improve what we're doing, and we plan to do that. In terms of sort of additional information on this, we will send out the questions we haven't managed to answer here. We'll send out written responses to. This is recorded. Please do play back the recording, distribute it to your colleagues. We'll share the decks as well. As I mentioned again, you should have had I think has been pushed out, details of the event in Barcelona was pushed out on the chat. If not, if you didn't manage to pick that up, then you can contact us about that as well. But in the meantime, I'd just like to say thank you very much to our contributors, to Phil, Miran, and Ian. And this is goodbye from London and from Chris. And thank you very much for joining us.